part. Boron to aluminum. Look at this. Yesterday we discussed this point. Boron to aluminum, the atomic radius increase. Gallium it decrease. Later increase, slight increase. So the values support your statement. The top to bottom the radius should increase, but only from boron to aluminum it increased. Later suddenly at gallium it decreased. So 85 picometers boron atomic radius, aluminum atomic radius is 143. So boron to aluminum increased. Aluminum to gallium 135 decreased. Again increased 167. And thallium it is 170 picometers. So what do you write the correct order? Write the correct order. Thallium greater than, indium greater than. Thallium is highest, greater than indium, greater than aluminum, greater than gallium. The smallest is boron. Similarly, we already discussed about ionization energy, but you see the electronegativity values also. See this slide. Electronegativity top to bottom it should decrease. So boron to aluminum decreased. What is the value of boron? 2.2. Aluminum 1.5. But later gallium, indium, thallium, the electronegativity increased. Already the answer given due to poor shielding effect of 3D and 4D and lanthanoid contraction. So this is one more point you have to add. Electronegativity in 13th group. Boron greater than, thallium greater than, indium greater than, gallium greater than aluminum. Based on the values you write thallium greater than, indium, next gallium, next boron. Lowest electronegativity is for aluminum, whose electronegativity value is 1.5 on Pauling scale. These values are in which scale? Pauling scale. See ionization energy order also. Boron to aluminum to decrease, gallium it increased, again decreased, again increased. The correct order you write. Decreasing order of first IE. Boron greater than, thallium greater than, gallium greater than aluminum, greater than indium.
So, Pardon. So, could you please repeat?
Decreasing order of IE, first IE. Here, this line. If you want, you can write the values also. Boron has first ionization energy 801 kilojoule per mole, aluminum 577, gallium 579, indium 558, thallium 589. This also we already discussed. Borax structure. In sp2 hybridization, how many borons are there? sp3, how many are there? This entire structure we discussed already. This borax bead test also we discussed. Orthoboric acid also we discussed. Right, one more point here. Orthoboric acid has intermolecular hydrogen bonds and forms a two-dimensional sheet-like structure. So banana bonds are bridge bonds. Yesterday we discussed. But in the same structure you write 120 angle here and 97 angle here. Here 120, here 97. This structure you can see. We mentioned the bond lengths also. Terminal bond lengths are 119 picometers. Bridge bonds are 134 picometers. Already structure is there, but just you mention the bond lengths and bond angles. Also mention in B2H6, write a point. In B2H6 diboron, boron atoms are sp3 hybridized. In B2 it's 6, diborane. Boron atoms are sp3 hybridized. sp3 hybridized. There are 4 sigma sp3s bonds. There are 4 sigma sp3s bonds. And 2 sigma sp3 sp3. These ones are sigma sp3s. This is also sigma sp3s. These ones are sigma sp3 sp. This is sigma sp3s. The diborane structure for now you write this one, first reaction, that is lithium aluminum hydride, this one. Yesterday we already mentioned when lithium hydride reduced with BCl3, this is one more in our syllabus. LiLH4 plus BF3. Or diborane preparation, one more method. Lithium aluminum hydride reduced by boron trifluoride. In the carbon family, you write this point. Electronegativity. Carbon 2.5 greater than silicon 1.8 is equal to germanium 1.8. Tin also 1.8 and lead is 1.9. So carbon greater than lead greater than silicon is equal to germanium is equal to tin. This is the electronegativity order. Why that order? From germanium onwards, pore shielding effect of d orbitals. We already discussed this point. Here one or 2 points are there. In C60, write the next point. In C60, a football shaped structure, there are 20 hexagonal 6-membered rings. There are 20 hexagonal 6-membered rings. This point I am talking. 20 hexagonal and 12 pentagonal 5-membered rings. Every ring in this structure is aromatic. This point is important. This football structure has a combination of hexagons and pentagons. How many hexagons are there? 20. How many pentagons? 12. Right, silicones. One more point you have to add here. Silicones. Silicones are like ketones. Like ketones. They are organosilicon polymers. They are organosilicon polymers. Containing a repeating monomer or SiOR. You write this one. Silicones are organosilicon polymers containing a repeating monomer unit n times RSIRO, monomer repeating unit. Second point you write, silicones are water repellents. Silicones are water repellents, electrical insulators, lubricants, and also used in cosmetic surgeries. And also used in cosmetic surgeries. Suppose suddenly you are interested to enter into movie field, cinema field, you want to become an actor. You want to change your face, maybe your nose, your cheeks, whatever you want. If you go to a plastic surgeon, by 3D animation, first you will take the photographs of your face and you will apply the computer knowledge to change your face and show you different faces. You want like this, like this, like this. Whichever face you like, more appealing, that face you will select. Based on that, you will do a surgery, cosmetic surgery. Suppose you want to bulge your cheeks, you will put some silicone implants in the cheeks. So whenever there is some upliftment of your body by cosmetic surgery, silicones are used. So what are these silicones? Silicones are organic part and silicon part. RSIO. This is the repeating unit. It can be another R also. If this type of repeated units are there, you know R2C double bond Y is ketone. This is ketone. So instead of C, here silicon is there. So this is normal ketone, this is silicone. So what you have to write is preparation of silicones. Just write this equation, and this one. Total 3 you have to copy. 2RCl, alkyl chloride, heated with the silicon in the presence of copper catalyst, you will get R2SiCl2. This R2SiCl2 is subjected to hydrolysis. You will get R2SiOH twice. Dialkyl dihydroxysilane. Its name is dialkyl dihydroxysilane. Now this type of dialkyl silanes undergo polymerization forming silicone. So 3 equations you have to write. Write an important note. If we wanted to terminate, the silicon chain, the compound used is trialkyl silicon hydroxide. Trialkyl silicon hydroxide. Suppose if you use this trialkyl compound, suppose if this is also, I am substituting alkyl group, then the chain stops here. It cannot further progress. So what is the chain terminating substance? Trialkyl silicon hydroxide. With that the chain stops. If you won't do that, it will continue. With OH groups, it go on continue. That is also asked in the examination. It is there in our NCERT textbook also. Next, now regarding silicate, write 2-3 points. All silicates contain, first point, all silicates contain SiO4 4 minus as the fundamental unit. All silicates contain SiO4. Four minus. This is the fundamental unit in silicates. So what is its formula? SiO4 4 minus, which can also be represented like a triangle. This triangle, each corner, this circle represents oxygen. The central dot, SiO4. sodium aluminum orthosilicate. This is also called zeolite. You know, zeolites are used to remove the hardness of water. Sodium aluminum orthosilicate is also called zeolite, which are used to remove the hardness of water. Next point, if two SiO4 4 minus units, if two SiO4 4 minus units are linked by sharing one common oxygen, they are called pyrosilicates. They are called pyrosilicates. So you can write an SiO4 4 minus unit, but one common oxygen is sharing 2 units. So the shared oxygen do not have any charge. This is called pyrosilicate ion. Si2O7 total 6 minus. Si2O7 6 minus. So in pyrosilicates, what you find? 2 tetrahedra are shared by one common oxygen. Each one is a tetrahedron. This is one tetrahedron, this is another tetrahedron. 2 tetrahedra share a common oxygen. Then we call it as pyrosilicate. Examples, if you want, you can write sodium pyrosilicate, calcium pyrosilicate. Now write the next point. In cyclic silicates, within bracket SiO3 n times SiO3 n times and 2n minus, actually this is printing mistake. So let us assume that this is one tetrahedron. This is shared by another tetrahedron. write a point. In cyclic or chain silicates, two oxygen atoms of each tetrahedron are shared by other oxygen atoms. Whose general formula is SiO3 n times 2n minus. This is a cyclic silicate. Si3, each dot represents Si. O, how many O's are there? 1, 2, 4, 5, 6, 7, 8, 9. Si3, O9. How many minus? 1, 2, 3, 4, 5, 6. Cyclic silicate. The next point is in sheet silicates, three corners of each tetrahedron are shared with others. Here actually minus. Are shared with others, and their general formula Si2O5 n times 2n minus. Si2O5 n times 2n minus. If all the four corners, last point, if all the four corners of the tetrahedron are shared by other tetrahedra, they are called 3D silicates. Example, quartz, tridymite, and cristobalite. These are all examples of 3D silicates. Write another point. This question I am answering. Which of the following structure is similar to graphite? The answer is boron nitride. NEET 2013 question. Which of the following structure is similar to graphite? The answer is boron nitride. Bn. Now we go for 15th group. So in 15th group, write the heading in P block. We are going for 15th group. Nitrogen, phosphorus, arsenic, antimony and bismuth. So nitrogen, phosphorus, arsenic, antimony, bismuth. Atomic number 7, 15, 33, 51, 83. Atomic mass is not required. Electronic configurations are required. Nitrogen has helium 2s2p3, phosphorus, neon 3s2 3p3, arsenic, argon 3d10 4s2 4p3, like that. So electronegativity, there is no anomalous situation, top to bottom decreased, covalent radius increased, no problem. Melting boiling points are not required. Ionization energy, first ionization energy also decreased from top to bottom. So there is no much anomalous properties. Top to bottom ionization energy 1402, 10, 12 gradually decreased. Electronegativity 3, 2.1, 2, 1.9, 1.9. So there is no much anomalous properties like the earlier groups. But here you write one more point. Nitrogen cannot show pentavalency. Nitrogen cannot show pentavalency. Nitrogen cannot show pentavalency. Within brackets, can't form NCl5. Can't form NCl5. due to non-availability of, can't form NCl5, that is within brackets, due to non-availability of vacant d orbitals. Due to non-availability of vacant d orbitals. Next, bismuth, the last element bismuth, also not exhibit pentavalency. Bismuth also do not exhibit pentavalency due to inert pair effect. Due to inert pair effect. Laboratory methods, industrial method. Lab methods, sodium azide. On heating, sodium plus nitrogen. Pure nitrogen. Barium azide. Barium azide on heating gives barium plus nitrogen. This is also pure. Now this principle we use in car airbags, nowadays the cars are fitted with airbags. Whenever an accident occurs, whenever two cars had a head-on collision, or when a car collides a stationary object like a tree or a pole, electric pole, or a road divider, if the impact of the collision is very high, immediately the airbag opens. There is one airbag in the steering, one airbag in the front part of the bonnet. The high-end cars backside also airbags are there. So immediately as soon as the accident occurs, the airbag opens. So the reason is, by noticing the impact of the collision, the sensors will send an electrical signal into the airbag. The electrical signal immediately sends a electrical spark into the airbag, where sodium azide or barium azide are present. They immediately decompose, giving nitrogen gas. This gas will inflate the balloon. and this balloon acts as a cushioning material between you and the hard parts of the car. Generally in accidents, people crush between the seat and the hard part of the car. They crush and die. To prevent from crushing, because your inside body parts are so sensitive, so any crushing occurs, internal bleeding occurs, that ultimately results in death. The person looks normal, external no injuries, but after taking to hospital he will die, because internal bleeding occurs. So to avoid that crushing, this airbag phenomenon was introduced. So nowadays, people who wear seat belt, along with this airbag is also there. It almost gives more than 90% of protection to you. So airbag should be there. You should also wear the seat belt. So these will give utmost protection. So the principle in airbags is the decomposition of sodium azide or barium azide, liberating nitrogen gas. So these are the two lab methods where pure nitrogen is prepared. Now the next method, sodium nitrite, not sodium, ammonium nitrite. Ammonium nitrite. On heating, gives N2 plus 2H2. This is one more method in the lab. Finally, the fourth method is reduction of cupric oxide by ammonia. Gives copper plus nitrogen plus water. So in the lab methods, 4 methods, 1, 2, 3 are very important. 4th method you have studied in your redox reactions. So 4th method also is discussed in redox. Immediately, students should ask a doubt, why you are preparing nitrogen? Because nitrogen is already present in the earth atmosphere. How much? 78% nitrogen is present in the air. Why to prepare nitrogen? So industrially, if you want large quantities of nitrogen, we don't use any method. Air is our raw material. Air contains nitrogen. To how much percentage? 78%. That's the industrial method. It involves fractional distillation of liquid air. Fractional distillation of liquid air gives nitrogen. And this is what nowadays after COVID-19 many people die because of lack of oxygen in hospitals. So that's why people are cautious nowadays. they are purchasing oxygen concentrators. At home itself, you have a portable oxygen concentrator. What it will do, it costs around 40,000-50,000. So in COVID time, there is a shortage and rates are increased to very high levels. So what this oxygen concentrator will do, it will absorb atmospheric air and remove nitrogen. 78% nitrogen is removed in the machine. Remaining 21% oxygen, that is directly put into your nostrils. So your oxygen supply is uninterrupted. No need of panic, rushing towards hospital because of lack of oxygen. So nowadays it has become like a pulse oximeter. Every house we purchased to know how much oxygen is saturated in the blood. Percentage of oxygen saturation. Pulse oximeter. That is very less cost. 1,000 rupees you will get a good quality pulse oximeter. You just put it in the finger and observe for 2 minutes. Should be in healthy human beings, it is 98 to 99%. Even more than 95% is allowed. Below 95, it is falling down. Your oxygen levels in the blood are less. Immediately need oxygen help. So two gases from the air, atmospheric air, which are industrially prepared, are nitrogen and oxygen. So here I write one more note. Oxygen is also industrially prepared by the fractional distillation of liquid air. Industrially O2 is also prepared O2 is also prepared by the fractional distillation of liquid air. So in the nitrogen family, we discussed about the preparation of nitrogen in the lab methods as well as industrial method. Industrial method have no equations, simply a word, a sentence. That is, industrially nitrogen and oxygen are prepared by the fractional distillation of liquid air. You write this point. Common oxidation states of 15th group elements are -3, +3 and +5. Bismuth do not show +5 state due to inert pair effect. Bismuth do not show +5 oxidation state due to inert pair effect. Now nitrogen in N2O it shows +1. In NO +2. N2O3 +3. NO2 +4. N2O5 +5. So So nitrogen shows what kind of oxidation states? +1 to +5 in its oxides. This point is important. In +1 to +4 state, this point I am adding. From +1 to +4 state, nitrogen disproportionates in acidic solutions. From +1 to +4 state, disproportionates in acidic solutions. Example, you write this one. This is also given in your NCERT textbook. So here it is +3, +3 to +5, +2. +3 to +5, oxidation. +3 to +2, reduction. If same element undergoes both oxidation and reduction, we call it as disproportionation. So HNO2 is nitrous acid. Nitrous acid disproportionate into nitric acid and a nitrogen oxide. Write the heading hydrides. Nitrogen form NH3, phosphorus form PH3. It forms ASH3. Antimony forms SbH3. Bi forms BiH3. This is ammonia, phosphine, arsine, stibine, bismuthine. Due to increase in the atomic size, down the group, and increase in bond length, and decrease in bond strength the following properties are affected. Number one, thermal stability. Thermal stability, reducing character, so thermal stability ammonia is more stable than phosphine, than arsine, than stibine, than bismuthine. Reducing character. BiH3 greater than, SbH3 greater than, so top to bottom the atomic size increase. You all know, when atomic size increase, bond length increase, bond strength decrease. Thus why stability decrease. What is this reducing character? Within brackets, ability to give hydrogen. What is reducing character? Here, ability to give hydrogen. So who will give hydrogen more easily? The one that is least stable will readily dissociate and give hydrogen more easily. That's why bismuthine is the best reducing agent. Since ammonia is the most stable, this is having less ability to donate hydrogen. So we discussed this property, reducing character. Next, bond dissociation enthalpy also discussed. Next point. Lewis basic strength. Lewis basic strength decreases from ammonia to bismuthine. Lewis basic character. Lewis basic strength or character decreases from ammonia to bismuthine as the size of central atom increases. As the size of central atom increases, the lone pair gets the lone pair gets more and more diffused into the space. The lone pair gets more and more diffused into the space and not available for donation. Are not available for donation. So bond angle, ammonia bond angle is HNH bond angle is 107 degrees. In pH3, HPH bond angle is only 92 degrees. In arsine it is 91 degrees. In stibine it is 90 degrees. In bismuthine, unstable, not formed. So in bond angle in ammonia, due to sp3 hybridization, here the bond angles are 90 due to p orbital, due to p orbitals involved in bonding. Next, boiling point. Boiling point. Ammonia to phosphine. Boiling point decrease. Later it increase. This is not formed, no need. First decreases, later increases. The correct order is SbH3 greater than ammonia, greater than arsine, greater than phosphine. This is a very, very important point. The acidic hydride, of nitrogen is N3H, called hydrozoic acid. With oxidation state -1/3. So what is the acidic hydride of nitrogen? N3H. This N3H is called hydrozoic acid. Hydrozoic acid. salts of hydrozoic acid are called azides. Salts of hydrozoic acid are called azides. Already we discussed about sodium azide, barium azide. In which of the following, write a question. In which of the following nitrogen has the lowest oxidation state? In which of the following nitrogen has the lowest oxidation state? Number 1, ammonia. Number 2, N3H. Number 3, N2H4 called hydrazine. Number 4, NH2OH, hydroxylamine. So what is your answer? In which case nitrogen has the lowest oxidation state? So in ammonia it is -3, -1/3, -2. Here +3 means +1, -1. -1, oxygen -2, total -3. 3 hydrogens +3, yes. So what is your answer? In which case nitrogen has the lowest oxidation state? The answer is ammonia. Students go wrong. They choose N3H. Why N3H is wrong? Because it is -1/3. When compared to -1/3, -3 is even smaller number. So that is the answer. Phosphorus form one more hydride called diphosphine. Diphosphine P2H4, which is highly unstable, and catches fire when exposed to air. Phosphorus form one more hydride called diphosphine P2H4, which is highly unstable and readily catches fire. I think you studied about Ohm's signal earlier. in the ships, Ohm's signal functions due to diphosphine only. It is there in your notes, you can refer. Now, write one more point. Ammonium dichromate. Ammonium dichromate on decomposition gives ammonium dichromate on decomposition gives nitrogen which is called chemical volcano. This is ammonium dichromate. It gives nitrogen. The entire experiment looks like a volcanic eruption. Thus it is called chemical volcano. Chemical volcano. Can I erase? So during science fairs, experiments, the thrilling experiment is this one. Industrially, ammonia is prepared by Haber's process. Write one more point. Industrially, ammonia is prepared by Haber's process, applying Le Chatelier's principle. Applying Le Chatelier's principle, you write this equation. N2 gas plus 3H2 gas, 2NH3 gas, delta H is equal to minus 46.1 kilojoule mole inverse. N2 gas plus 3H2 gas gives rise to 2NH3 gas. It is an exothermic reaction. Delta H is equal to minus 46.1 kilojoule per mole. The favorable conditions for the forward reaction are the favorable conditions for the forward reaction are number one, high pressures. High pressures within brackets 200 to 1000 atmospheres. Number 2, optimum temperature. (773 Kelvin). Number 3, catalyst. Powdered iron. Number 4, promoter. Molybdenum or K2O and Al2O3. So what are the favorable conditions for ammonia formation? Very high pressures, 200 to 1000 atmospheres. Optimum temperature 773 Kelvin. Catalyst is powdered iron. Promoters are molybdenum or oxides of potassium and aluminium. Next, write two important reactions in which ammonia acts as a ligand. Ammonia acts as a ligand. Number 1, cupric sulfate aqueous plus NH3 liquid. So CuNH3 4 times SO4. So write 4 NH3 here. This is already blue. This blue become deep blue. Blue become deep blue. The name of the complex is soluble in ammonia liquid. To form a soluble compound, diamine silver 1 chloride which is a soluble compound. Most important is to so in both these reactions, ammonia acts as a ligand. Ligand means electron pair donor. It is a Lewis base. Ligand and Lewis base, almost you can use the word interchangeably. Both have the same sense. Next question. Write the reaction of ammonia with chlorine. So ammonia plus chlorine excess. Ammonia plus chlorine excess. You will get NCl3. NCl3 plus 3HCl. In the second one, ammonia excess plus chlorine. This forms ammonium chloride plus nitrogen. This is one set, very important. 8NH3 plus 3Cl2. So in one case chlorine excess, in another case ammonia excess. Here chlorine excess. Or next, write the oxides of nitrogen. Oxides of nitrogen. So nitrous oxide, nitrous, nitric. First one is nitrous oxide. This nitrous oxide is also called laughing gas. Next one is nitric oxide. First two are neutral oxides. Both are neutral. Next is the name same, dinitrogen trioxide. So everything is same. You have to repeat this entire table. N2O, NO, N2O3, NO2, N2O4. N2O5. So oxides of nitrogen, so first two are neutral oxides, all the remaining are acidic oxides. Acidic. Their preparations are also given. Here you can also further simplify. NO plus NO2 cool N2O3. Now this is called dimerization of NO2. Write a point here. NO2 is reddish brown and paramagnetic. NO2 is reddish brown and paramagnetic, which on cooling dimerizes to form a colorless N2O4, which is diamagnetic. So we are talking about this one. This is called a dimerization. Reason: the two unpaired electrons gets paired. The two unpaired electrons gets paired. So these are all the structures of oxides of nitrogen, N2O, NO, N2O3 and NO2. NO2 you have one single electron here. In NO also. These structures you have to practice from an NCERT textbook or anything. All structures are important. No need of this bond lengths, bond angles that become too memory type. But resonance structures, Lewis dot structures you should know. You can write here HNO3, nitric acid. Nitric acid preparation by two methods. One is called Ostwald's method. Ostwald's method. The second one, Birkeland and Hyde method. Birkeland, which is also called arc process. So in Ostwald's method, ammonia is oxidized. This is the first step. Second step, NO is further oxidized to NO2. In the third step, the formed NO2 is dissolved in water in the presence of oxygen to form HNO3. This is Ostwald's method. Here platinum catalyst. Here air contains N2 78% by volume and O2 21% by volume. That's why this N2 and O2 N2 and O2 from the air subjected to electric arc. And the arc temperatures are more than 3000 degrees centigrade. Then you will get nitric oxide, 2NO. Now the second step is same as in Ostwald's. 2NO plus O2 gives rise to 2NO2. Of course, these are all in gaseous state. Last step also same as in Ostwald's. 4NO2, 2H2O, 4HNO3. This is all nitric acid preparation. How many methods? Two methods. One is called Ostwald's, the other is Birkeland and Hyde's method. So in Birkeland and Hyde method, the N2 and O2 directly present in the air. Air is our raw material. So they are forced to combine to form nitric oxide, which is converted into nitrogen dioxide. which is absorbed in water in the presence of oxygen to form nitric acid. HNO3 is a nitrating agent, oxidizing agent. So when it comes in contact with the skin, it forms yellow coloration because the proteins of the skin are converted to xanthoproteins. So HNO3, when come in contact with the skin, yellow coloration due to the formation of xanthoproteins. It is an oxidizing agent because it gives nascent oxygen. HNO3 gives nascent oxygen. That's why it is an oxidizing agent. Laboratory nitric acid is yellow in color. Laboratory HNO3 is yellow in color due to the presence of dissolved NO2. Due to the presence of dissolved NO2. Okay, you take a break now. After that, we'll discuss the properties of nitric acid. So Dr. Rudolph is saying that today whatever you taught in the first session, no student followed. Correct? None of us followed. Up to yesterday it is very good. Today it is very bad, horrible. Then I asked the same teacher how you will different from yesterday to today. So only thing to save time, we are showing a PPT or a PDF in which all the important points I am explaining again. And wherever there is an additional information required, for example, ammonium dichromate decomposition I gave to give nitrogen. I mentioned it is a chemical volcano. That is very important because it is a general knowledge question also. Whenever you go for a science fair or your brother or sister want to show something new in the school projects, we advise them to purchase a packet of ammonium dichromate, arrange a small electrical resistance wire inside it with a 1.5 volt battery. So when you just switch on the battery, the resistance wire become hot. Small wire of 1.5 volt battery. Then ammonium dichromate used to explode like a volcano. It looks like a volcanic eruption. You can say mini volcano. That's how we call it as chemical volcano. Similarly, I also mentioned how to prepare pure nitrogen by decomposing the azides, sodium azide, NaN3, or barium azide, BaN3 twice, to give pure nitrogen. Of course, that two reactions are also used in filling the car airbags. Whenever a car met with an accident, the airbags automatically open up due to decomposition of either sodium azide or barium azide. So these are all simple points only. So any student have the responsibility, whether it is Rudolph or XYZ, whosoever it is. When you are not able to follow, you ask me to repeat. I will repeat it, what is there? Because ultimate goal is your goal, your parents' goal, my goal, Meghalaya government's goal. All goal is same. You to become a doctor. Correct or not? So we are all striving for that. So we are all having a common goal. To achieve common goal, we are ready to do hard work. You are also ready to do, you are doing it now. You are doing it. Still 6 months time is there. So you can increase your pace, your concentration. So now and then, or now onwards, whenever you don't follow any line, word, you ask me to stop and repeat. That is your duty. That is a preliminary responsibility of a learner. Simply sitting and watch this bloody fellow is boring us, and after that you feel very sorry. Ultimately your time is wasted. So the moment you have to give a check to the teacher also, whosoever he is, botany, zoology or physics, chemistry, whosoever, when you are not following, it is your duty to ask, to repeat, revise. Okay? So in the morning session, What you have not followed? So Rudolph is saying that a single line I have not followed. Maybe the structural aspects of silicates, silicones, they're a little bit tougher because you have to write the structure. Silicates are SiO4 4 minus. So that silicate, if SiO4 4 minus separate units are present, they are called orthosilicates. If two SiO4 4 minus units are joined together with sharing a common oxygen, we call them as pyrosilicates. If two oxygens of the two corners of a tetrahedron are shared with others, we call them as cyclic or chain silicates. We have given a formula SiO3 n times, total 2n minus. If three oxygens of three corners of each tetrahedron are shared with others, you will get sheet silicates. For example, mica is a sheet silicate. Your clay, black soil, is a sheet silicate. If all four corners of the SiO4 4 minus are shared with others, you will get three-dimensional silicates. I have given the examples of quartz, tridymite, cristobalite. These are all different forms of quartz. Quartz is an example of, they will give a question like this in your NEET. Quartz is an example of A, orthosilicate, B, chain silicate, C, cyclic silicate, D, three-dimensional silicate. Your answer is D. So here what we are giving, all the necessary inputs. Those inputs must be well grasped by you, revised by you, reproduced by you in the examination. Three things must happen. Teacher should teach all the necessary information. Information should be gained by the learners, that you are the learners. The learners not only grasp the things, revise the things, discuss with friends, reproduce exactly in the examination. I waste a little bit, 1 or 2 minutes time. In our ancient India, that is called pastoral India. The learner is in search of guru. Teacher is in the forest. No schools, no colleges. The teacher, the guru, is in a forest, a deep jungle. The learner will be in search of that guru. So once you reach that ashram in a forest, a particular place, the teacher may accept you, reject you. Even the king, he will take his son, his would-be king, prince. The prince also has to go to the jungle. He can't hire the guru to his courtyard. So what the teacher will teach him? He won't teach anything in the beginning. Simply they have to take the cows to the forest. Every day come back, get some firewood, fetch firewood for doing some rituals or cooking the food, whatever it is. And they are fed with the food. They all sleep on the floor, the mats. Early morning the guru wakes up, go to a river for taking morning bath. So whether it is winter or summer, whatever it is, all the disciples should also go there. Along with the guru, they take a dip and come to the thing. This is the thing happening there for a pretty long time. Meanwhile, some students cannot cope up this, they will say goodbye and go. He won't object. Like that, after accustoming to the situation, then he used to teach something. What he teach? He will teach literature, art, the art of war. He is not a single man. He teaches all, dance, music. So he is a multifaceted personality. He teaches all. Once the disciple comes out of ashram, he will become perfect in many fields. He can fight with others, he can sing, he can dance, he can discuss in literary discussions. So that is our ancient system, Indian system of education. Like the Nalanda University in Bihar, Takshashila University. These are all our ancient universities where foreign students come and write an entrance test and join there. Indian academic education standards are very high. But with the advent of British, when Britishers, East India Company started in India, Lord Macaulay sent a message, wrote a letter to the King of Britain that by introducing English language, we can spoil the entire Indian education system. Why English language is in the need of hour? Because Britishers want to communicate with local farmers who produce their crops. They have to pay some taxes, revenue. So to communicate with farmers, they encouraged the setting up of these church-based convents. Convent is a place where nuns are there. Convent is not a school where Christian nuns will be there. It is also called abbot. A-B-B-O-T. Abbot and convent are one and same. So they used to establish the churches connected to a school where English is taught. So those who learn English, they are the top officers in British India, because they easily communicate with the Britishers in their local language to the farmers. Like that, the Indian original education system was totally gone down. People are mad behind to learn English. So after learning English, they started giving degrees. Look at your great grandfathers. They're all BA, MA, no science, Bachelor of Arts, Bachelor of Commerce, mainly arts and commerce graduates in the British India. So after 1947, India got independence. We later introduced science as one of the subjects in our system, because Jawaharlal Nehru started the 5-year plans. We constructed hydroelectric projects and multi-purpose dams. These all require engineering as one of the key subject, and also medicine, because in India mortality rate is very high at that time. Cholera cannot be controlled, TB cannot be controlled, leprosy is more, plague is there. So our normal viral, fungal, bacterial infections could not be controlled, because even penicillin was discovered in 1942, I think just at the beginning or end of the World War II. Alexander Fleming discovered penicillin, which is the most potential form of antibiotic. Actually, penicillin saved millions of lives in World War II, because all infections are cured by penicillin. Then bacteria became intelligent, it developed resistance. Penicillin, they said, we eat penicillin and live. Then another class of antibiotics which can kill gram positive, gram negative, bacteria. So amoxicillin based, ampicillin based, many antibiotics. Now we are running with fourth generation antibiotics. So of course, like this Indian system evolved, one side technically, one side medicinally, one side agriculture, crop production. So like that we evolved and now we become a world leader now almost. Still, the system of education has to be improved. So all the medical colleges are not fully equipped with professors. So though medical colleges are more in number, every year every state is introducing so many medical colleges, but no staff, no dead bodies to dissect anatomy, to do anatomy practicals. Dead bodies are also less. So 20 students only observing what the professor is telling to understand the anatomy of a leg or a hand, whatever it is. When 20 students group around a professor, their observation will be very less. So that's why only few medical colleges like AIIMS, some government-based medical colleges, in private segment also, like Kasturba Medical College in Manipal, or Christian Medical College, Vellore. So they are doing very good services, or they are giving good medical knowledge to the students. So this is how our systems has fallen down. So we have to, as educators, we are also thinking how to introduce a more efficient way of teaching and less burden to the student. That is one of the things is digitalization. Of course, this digitalization, it requires a bigger board with a more contrast and colors. Then you can easily grasp it, because this is a rectangular room. I also observed in the last, you can't see it properly. So there is also some logistical problems are there. Okay, now onwards, in my class, if anything is not followed, immediately ask. Okay? And this is already soft copy is available, I think, in your systems. It can be introduced into your tablet. So when it is introduced, you go through the tabular form, because I have just shown the nitrogen oxides tabular form. Again, I don't write the entire table repeated. So, but you follow the tabular form, write the structures. If you have any doubt, you can again ask. In the class itself also you can ask. Now we are going for the properties of nitric acid with metals, that is there in the display on the board. You write a point. Action of nitric acid on metals. Action of nitric acid in metals depends on number one, nature of the metal. Number two, concentration of the acid. Concentration of the acid. Yesterday, you said you followed it. Yesterday I discussed one point. What is the product when aluminum reacts with concentrated nitric acid? Very good. Most of the students are able to answer. No reaction, because aluminum forms a protective oxide layer, and beryllium also in second group. That is called passivity. So it depends on the nature of the metal. Aluminum plus concentrated nitric acid, no action. So it all depends on the nature of the metal, concentration of the acid. Two factors depend. Here see the first two, copper plus dilute HNO3. We are getting cupric nitrate plus NO plus H2O. Same copper with concentrated nitric acid, it is giving NO2. So write the first two. This is one important point. Copper plus dilute HNO3, cupric nitrate plus NO plus H2O. Same copper metal but concentration is changed. Here dilute acid, here concentrated acid. Hope you know the meaning of dilute and concentrated. Whenever water is added, it becomes dilute. Whenever no water is added, the acid becomes concentrated. So, with concentrated, Cu plus, first reaction I read, 3Cu plus 8HNO3, within bracket dilute, 3CuNO3 twice, plus 2NO plus 4H2O. Second reaction also I read, Cu plus 4HNO3, within bracket concentrated, cupric nitrate, CuNO3 twice, plus 2NO2 plus 2H2O. But look at with the zinc. With zinc, the scene is different. Zn plus 10HNO3 dilute. Zn nitrate, zinc nitrate, here N2O you got. But Zn plus concentrated nitric acid, you are getting NO2. Same zinc metal with dilute N2O, with dilute copper is giving NO, with concentrated it is giving NO2, it is also giving NO2. Here I write aluminum plus HNO3 concentrated. I write no action. Beryllium plus HNO3 concentrated, no action. So here basically you should understand, metal plus HNO3 gives metal nitrate, this is common, plus metal nitrate plus NO or N2O or NO2 or ammonium nitrate plus H2O. This is the crux of this entire thing. Metal plus HNO3 gives what are the two common things? Metal nitrate plus water is common. Along with metal nitrate plus H2O, what you may get? You may get NO, you may get N2O, or you may get NO2, or you may get ammonium nitrate. Here you are getting NO, here you are getting N2O, NO2, here N2O. So I will give one more example. Where you will get ammonium nitrate also. So I need a gap. Here I will take up. So here I am taking up Mg plus HNO3 dilute. Mg plus HNO3 dilute. MgNO3 twice plus 2H. This is step 1. Now the formed hydrogen again react with nitric acid to form ammonium nitrate. This is equation 2. To balance equation 2, write 2HNO3 plus 3H2O. Then hydrogens become 10 here. Then write 8H. 8H means first equation should be multiplied with 4. So 8H cancels. Now write the net equation. What is the net equation? 4Mg plus 10HNO3 gives rise to 4MgNO3 twice plus NH4NO3 3H2O. So metal plus nitric acid what are the products? We don't know. It all depends on the nature of the metal, concentration of the acid. We know two products are common. Metal plus nitric acid gives metal nitrate plus H2O common. Along with H2O and metal nitrate, what you may get? You may get NO, you may get N2O, you may get NO2, or you may get last ammonium nitrate. So with the zinc and dilute nitric acid, we are getting N2O. Memory recall question. No other go. JEE exam, this question is asked. Zn plus HNO3 dilute, which gas is liberated? The answer is N2O. Student, if knows, he can recall it and write the answer. So metal plus nitric acid, the products all depend on two factors: nature of the metal, concentration of the acid. If aluminum and beryllium are used, no reaction occurs. Why? Due to protective oxide layer, and the property is called passivity. The dictionary meaning of passivity means to become silent. Passive means to become silent. Who are becoming silent towards whom? Metal is becoming silent towards nitric acid. That's why the property is called passivity. Sulfuric acid. So this is one part. When non-metals react with concentrated nitric acid, what you are going to get? They are oxyacids. Carbon to carbonic acid, phosphorus to phosphoric acid, iodine to iodic acid, sulfur to sulfuric acid. This one part you should know. Today our software engineer is not there. Software engineer. Because he takes responsibility of filling ink in the pens, looking after all these things. Okay. Now here I will go, or I will ask you your preparedness when phenol reacts with dilute nitric acid, HNO3 dilute. Yes, anyone? Phenol reacts with dilute nitric acid. You will get a mixture of orthonitrophenol, paranitrophenol. Ortho and paranitроphenols. Here one more important neat question is there. A mixture of ortho and paranitроphenols is separated by, very good, steam distillation. Because orthonit, we discussed in hydrogen bonding. Orthonitrophenol has intramolecular hydrogen bonding. Paranitrophenol has intermolecular hydrogen bonding. One is steam volatile, the other is steam non-volatile. It is there in your chemical bonding notes. Under the heading of hydrogen bond, you wrote all these points. Same phenol, concentrated nitric acid. Very good. You will get a 2,4,6 trinitrophenol, which is popularly called as picric acid. You are getting 2,4,6 trinitrophenol called picric acid. Picric acid, an yellow crystalline solid with explosive nature. He also mentioned that. Picric acid is a yellow crystalline solid with explosive nature. I'll also ask you one more question here. This is glycerol or glycerin? Glycerin or glycerol. One, two, three propane triol IUPAC. 1, 2, 3 propan triol. When this is treated with HNO3, HNO3 I am writing as HONO2. Concentrated. Concentrated nitric acid, I am writing in the form of HONO2. Total it become HNO3 only. So obviously what I am going to do, a water molecule is eliminated from OH group and H plus. 3 water molecules are eliminated. So you got CH2ONO2, CHONO2, CH2ONO2. It is called glycerol trinitrate or nitroglycerin. Nitroglycerin. Or popularly called as dynamite, an explosive. So this is the work of Alfred Nobel, a Swedish industrialist cum chemist. Alfred Nobel is a Swedish national. He is a chemist and later became an industrialist also. He discovered this dynamite, glycerol trinitrate or nitroglycerin, an oily liquid with powerful explosive nature. And it is a patented product. So whenever the governments want to make railway lines, roadways, to blast the hilly areas, we use dynamite as an explosive. Or the contractors, when they want to construct a bridge, they will be given permission to purchase dynamite because it's not available in the open market. Only with the collector, district magistrate, if he says this is a contractor, he needs this much dynamite, they will supply that much. Because it is a dangerous explosive. And every year, the Nobel Committee will get huge revenue from the entire world because it is a patented product. Whosoever manufacture dynamite, they have to pay some royalty to Nobel Foundation, Swedish Academy of Sciences. So this single compound is earning huge amount of money per year. With that money, a part of that money is used for giving Nobel Prizes. So the explosive compound responsible for Nobel Prizes is this one, dynamite, discovered by Alfred Nobel. Like that, nitric acid not only involved in inorganic part, organic reactions also there. Like phenol react with nitric acid, glycerol react with nitric acid. Of course, some extremists, some terrorists, they also make dynamite in a forest. And nobody knows they are making dynamite. They use it to blast the military vehicles. They use it to kill the civilians. So destructive purpose also dynamite is used. Constructive purpose also it is used. So this is all about nitric acid. Nitric acid has many uses. The salts of nitric acid are called nitrates, which are important fertilizers for the plants. Salts of nitric acid are nitrates, important fertilizers. Nitric acid is used for making explosives. It is also a nitrating agent. It is an oxidizing agent. What are the important uses? As a nitrating agent, as an oxidizing agent, for making explosive compounds, for making fertilizers. So these are all the uses of nitric acid. Okay, we'll discuss some more. We have in this chapter chlorides and oxoacids of phosphorus. So small areas are there. In the next class we will discuss that, and 15th will be over. Today is only Friday, 16th, 17th, 18th. Comfortable, we can complete the entire P block. If possible, P block and the remaining part of thermodynamics. That this time we cover. That is our aim. Okay?
Ini